Hello friends, hello, welcome to all of you GMK tutorials. So today we are going to start one of the new subject, that is nothing but network analysis. Okay, network analysis plays a very important role in every subject. It is not only useful for electronics and communications and electrical engineering, it is also one of the important for analyzing the circuits in any branch, maybe EIE, electronics and instrumentation engineering, ECE, EEE. Okay, so for that purpose we are going to start a network analysis subject. So first of all, let us see, generally network consisting of a different elements, right? Network consisting of a sources, comma, elements. Okay, generally sources may be voltage source and current source. Here elements means that like passive elements, okay. So here passive elements means that we generally know that RLC components, okay. RLC components are generally called as a passive elements, okay. So here sources means that like voltage source and current source. So here elements is nothing but maybe another voltage source, and sources also generally called as a active elements also. Here active elements means that which gives the energy. So these RLC components are stores the energy, or passive elements means that which absorbs the energy, okay, which absorbs the energy. Okay, passive elements means that which absorbs the energy. So active elements means that which gives the energy. Okay, generally suppose if you want to define the active elements means that which provide or gives energy, right? So in that, like voltage source, general example is nothing but voltage comma current sources, okay. So that is one of the classification. After that, if you see the resistor and inductor and capacitor, resistor dissipates the energy, right? So inductor is nothing but which stores the energy in the form of electromagnetic field. Inductor means that inductor stores the energy in the electromagnetic field, okay, the electromagnetic field. As well as capacitor stores the energy in the electrostatic field, okay. Inductor stores the energy in the form of a electromagnetic field, capacitor stores in the form of electrostatic field. So that is one of the differences. So if you want to analyze this, so generally if you want to write down the formulas for voltage and current for inductor and capacitor, generally VL is equal to, okay, so generally I is equal to CL into, sorry, so for capacitor I can represent VL for inductor and VC for capacitor voltage and IL for inductor and IC for capacitor. Okay, I can make it just a normal notation for you identifying the corresponding sources. Suppose if you want to write down the VC voltage across the capacitor, VC is equal to 1 by C integral of I dt. So this is a voltage of capacitor. So from that we can represent the IC is equal to C into dV by dt. So that is the current across the corresponding capacitor. So as well as if you want to write down the equation for inductor So V is equal to L into di by dt. So this is nothing but voltage across inductor, voltage of the inductor. Okay. So as well as if you want to write down the current equation, I is equal to 1 by L into integral V dt. So that is the formulas, those are the formulas for voltage and current for both inductor and capacitor point of view. So up to now it is very clear for some basics, right? So voltage source as well as a current source. So in that it can be represented like this: voltage source is Vc is equal to 1 by C into I dt for capacitor. Current equation for capacitor is equal to Ic is equal to C into dV by dt. Voltage of the inductor VL is equal to L into di by dt, as well as for current equation I is equal to 1 by L into V dt. So these are all the different formulas useful for analyzing the networks. So after that, if you want to write down the one of the most important theorem is known as Ohm's law. Okay. Ohm's law is one of the most important law. So this is nothing but Ohm's law means that here Ohm's law can be represented. It is applicable for only linear voltage ampere characteristics only. It is applicable for linear voltage ampere characteristics only. Linear voltage ampere characteristics only. So therefore V is directly proportional to IR. V is directly proportional to IR. Therefore it can be represented as V is equal to I into R, where K is some constant. Okay. Therefore generally we can replicate, if you consider K is equal to 1, it can be represented V is equal to IR. Okay. So from this voltage V is equal to I into R. So it can be represented, denoted in a volts. For current equation, if you want to write down the current equation, I is equal to V by R. So it is denoted in amperes. So these are all the units for voltage and current for. Okay. So this is one of the important concepts for network analysis. In the next video, we will discuss about the what is meant by Kirchhoff law, Kirchhoff current law and Kirchhoff voltage law.